It truly is a great pleasure for me this morning to introduce my good friend, Dr. Shannon Haymond. Dr. Haymond received her PhD from Michigan State University, and she did her fellowship, postdoctoral fellowship in clinical chemistry at Washington University in St. Louis. After that, she moved to Northwestern University in Chicago, and she's been there since she finished her fellowship. So she is currently the immediate past president of the Association for Diagnostics and Lab Medicine, formerly AACC. In fact, Shannon, I think you will be the last president of AACC because the
Yes.
organization has changed its name. Dr. Haymond is the vice chair for computational pathology and the director for clinical mass spectrometry at the Anne and Robert Lurie Children's Hospital of Chicago, and she's an associate professor of pathology at Northwestern University's Feinberg School of Medicine. Dr. Haymond's computational pathology efforts are aimed at building the capacity for advanced data analytics in her department through innovations in infrastructure, education, and research to facilitate data-informed decision-making for clinical care, operations, and quality assurance. And Dr. Haymond more recently completed a Master of Science in Predictive Analytics from Northwestern University. Today, she is going to talk to us about the digital transformation of pathology and lab medicine. And Shannon, it's really a great pleasure to have you here. So please take it away.
Great. Thank you very much, Tony. It's great to be here. Good morning, everybody. Hello from Chicago. I'm going to talk about what we've been doing for effectively the past 7 years, and just broadly about this digital transformation as I see it of our departments of pathology and lab medicine. So I'm going to start off with my acknowledgments. This is really about changing culture, you'll see, and forging into a new domain that didn't exist for us 7 years ago. And it wouldn't have been possible without all of the people in our department. You'll see as we go through the presentation that I'm really talking about how we're trying to, as a core asset, develop this ability for computational pathology, as we call it. And so it wouldn't have been possible without everyone in our department, from the staff all the way to my fellow lab directors. But also because you'll see that this is about growth and new resources, infrastructure. It also required a lot of support from our chair, Elizabeth Perlman, as well as our executive director for the clinical laboratories, Dr. Demi Callis. So I would like to acknowledge all of them and say that none of this would have been possible or as enjoyable without the support of my department. So I'm very grateful for that. I've structured this talk into 4 sections. First, I want to lay out this opportunity to talk really about what I view as digital transformation, and hopefully talk about why we should do that and convince you that this is really important and that we should be doing it now. I'll talk about our process, like how did we build this at Lurie Children's. Then we'll talk about the value. I'll share some examples of how we've demonstrated the value of these efforts here. And finally, we'll close with some of my thoughts on some really exciting things that are coming in the future. So let's talk about the opportunity. So you may be thinking, as departments of pathology and lab medicine, we've been digital and data rich, as I would call it, for many, many, many decades, right? We've long had laboratory information systems. We've relied on rule-based systems that some people may say is AI in auto verification. And we've had these digital interfaces for orders and results for a really long time. But I would argue that this has not been consistent or purposefully applied. So often these are a means to an end, or what is required for us to scale and handle large volumes. But we really haven't been using this data to enhance and elevate maybe our services. And so that's what I really think this digital transformation is. It's how we're going to apply digital technologies and use data to really change things about our existing processes. So to transform those things that are not digital, to allow us to create and enable new methods for both decision-making and clinical service. And also to further our ability to scale and optimize our processes. And really thinking again, you may be a department where you may have worked in a department where there is one sort of tech savvy, informatics savvy person or a couple of people who do this. But really what this transformation is about, as you'll see, is trying to empower and engage all people in our laboratory and, effectively, hopefully in our institution to really leverage these digital assets. And I'd say, why now? So we're facing what I'd say is a time of great opportunity, and this is really requiring our action. So because we have been the product, as every industry has, of increasing access and digital data availability, I would say that the size and the depth of the data that's available to us as raw materials for this data-informed decision-making has never been more plentiful. It just keeps growing and growing. And I think, I'm hopeful that our access to this data is also improving in time. We couple that with the fact that our institutions have woken up and they're also really motivated to better utilize data assets. So that means they're investing heavily in this area. And I'm going to encourage you, if you haven't already, to find out what's going on in your institution and figure out how you can tap into those resources and use them for your own efforts. And finally, even if you're still facing barriers institutionally to access data or different tools and resources, we've seen a ton of open source software tools that are low code, no code, tons of tutorials, education that is available online, free or for very low cost, that's really making these efforts widely accessible. So that's all great. That's a great opportunity, but then there are some barriers to overcome. And I think that these are institutional and individual, and they're real. They're really, really some practical problems here. And so one is the mindset of leaders, but also of individuals, including, I think about where we started 7 years ago, and this is something we're continually working on and have had to overcome. But, this is not always the way that people have been operating. So people may be resistant to use data or some of these more advanced analytic applications for decision making. This kind of effort has not been valued or prioritized either operationally or academically, sort of viewed as a nice to have versus looking at it as something that's really a critical strategic investment. And then in the same vein, we've often been focused on, a singular thing. So how do we implement X or, bringing in instrument Y versus really taking a look and planning for the future state and then figuring out how that can shape all of those, individual decisions for projects and needs that are required in the department. In addition to mindset, we've got some technical limitations. So often, you may, as I said before, previous to, 7 years ago, we did not have a lot of the technology or infrastructure that we have today. So there's been a limitation in the ability to support this kind of work. We still face data access restrictions, though I'm hoping that some of those are getting better. And maybe even if you can access data, it could be that the data is still very siloed. So you have a lack of integration. You may not have access to all the data sources that you'd like or you'd need. What we have available to us could not be available or right for the job. And then there's this really practical problem that I think it's on us to solve for sure, which is that as a profession, all the way from our staff and to our leaders, we lack the necessary skills. And so I'm going to talk about what we've done here to try to build computational thinking and data literacy. And I think this is something that, we've really worked hard in our professional association of ADLM, and prior to that, it was AACC, to really put this as a focus, because I think for our profession, this is extremely important and something that we haven't yet addressed adequately. All right, so given all of that, let's talk about how we approach this then. So when I think about our roadmap for this, there are kind of 4 guiding principles, if you will. So one, we knew that we wanted to recognize what we've called computational pathology as a core departmental asset and specialty. We also knew that we didn't want to just build this alone in a silo in our department. And so we took an approach that we wanted to integrate all of the stuff that was important to our department, the data and the informatics systems, within Lurie infrastructure as much as it could. And that includes people, processes, and technologies. We wanted to create these digital processes that were robust, reproducible, and transparent. Like, we had a lot of things that were going on, but I would argue that none of them were these 3. And that was something that was a guiding principle for us. And really, to summarize it, we knew that we needed to advance our data analytics and informatics maturity. This type of concept has been called a lot of things: data science, pathology informatics. We've decided to call it or lab analytics. We've decided to call it computational pathology. And when I really think about what this means to us at Lurie Children's, it's really about how do we take data. Often this is from different sources. Some of it may be from our LIS that could or could not live within the medical record. There's medical record data, there's instrument data, there's individual databases from labs, from instruments, et cetera. How do we take all of that data, figure out how to integrate it and access it, apply computational methods and approaches to help us generate decisions and drive decisions? And we've thought about this as in 5 sort of tiers that have evolved over time, but this is my concept map for it. And we started in 2017 really trying to build up maturity for our analytics. Next, we really made more robust our bioinformatics group about a year later in 2018. And then we really started to focus on, okay, how do we pull together then and better organize our pathology informatics, which is really the backbone and the pipelines of all the things and the data flow and the access and the governance. And as well as building up our data literacy. So we got to a point where we were creating a lot of tools and had applications available, and we needed to make sure people could use those most effectively. And I'll talk about each of these areas, but then what I want you to know is that the one area that we haven't really done anything much with yet, but is what is next, the next area of focus on our roadmap is digital pathology. So let's step through each of these after we talk about how this building of maturity. So this ICMM is the Informatics Capability Maturity Model. And so in IT, IM, their analytics, there are these maturity models that get described. And so it's really about assessing your capability across a variety of perspectives, and there's 5 here that you're seeing. Those include how well you manage information, how well you're using data analytics, using informatics, how well your approaches and efforts are aligned with your departmental objectives and strategies. And then the last capability being, are you able to realize and demonstrate the benefit of these efforts? And typically then on a maturity scale, you go through multiple steps of it, but this particular one, the ICMM, starts at level 1 and it goes to level 5. And so let's look at what that looks like. And the idea here is that these are meant really for institutions, but I've found this is really helpful for our department to assess where we are in each of these capabilities and give ourselves sort of a grade or a level, and then think about then how do we continue to progress through this to the top level of this particular one, which is level 5. So in level 1, for this particular maturity model, when you talk about managing information, you've got what they call information anarchy, which I really like because I think that was an adequate description of where we were 7 years ago. But data is access is fragmented, it's inconsistent. Again, some areas are doing really well with it, others had no access, no interest. And then there were people, like we were in multiple areas. For instance, if we report a metric for turnaround time or critical callback, for instance, everybody was doing that and everybody was doing it differently. When we then think about our data analytics, at level 1, you really just have basic reporting and analysis. These reports and analyses are largely retrospective and they're highly manual, which is certainly what we saw. For informatics, again, these are often standalone. They don't create a large change in process. And typically the decisions are really focused on a product or a particular piece of software, something you want to implement without really considering a larger strategy. Find the next one being aligned with objectives. So again, isolated, these are viewed as what I'd call nice to have. And this is not really a key point in your overall planning as a department, or how, when you're bringing things in, you're not really considering the capability that this might give you for analytics or informatics. And then finally, the benefit. So people are resistant at this level. You have no ability to really recognize or document your value, and you really don't have somebody who's leading this as a change agent. So when we get all the way up the scale to level 5, which is where we want to be, you can see that, we've now transformed that our information is viewed as a strategic asset. We know about it. It's agile, the access, but controlled. And the data are reliable and integrated and very well known, like well documented. That means that in the analytics, we're able to, apply advanced analytics, which is things like machine learning and artificial intelligence. We've got a robust business intelligence profile. And instead of being manual, these reports, because we anticipate what people need and we know what they need and we know what people are using, we can automate them. And a lot of it is self-service. We then move to informatics, where we're now able to, tech is enabling innovation versus just being like a means to an end. We're making strategic investments in building capability versus just in installing or implementing a piece of software or an application. And now we start to see that we have the ability that our processes are transformed and we, are doing things different. From the aligned with objectives, we now have viewed this the culture has changed. So people view this as a must have. Whenever they're thinking about making a decision or when decisions are being discussed, they know what data is there, data is available to them, and we're able to make data informed decisions. We're thinking about this when we're planning. So for instance, we, made some decisions in our department of point of care. And it used to be that we would just try to get devices in, and often the IM pieces were lagging behind or they would slow us down. So we would concede and say, all right, well, we won't interface it now. We'll put that on the map for later. Of course, that later never comes because there's always something else. So now it's like, we know when we're bringing something in, we're going to say that this is a guiding principle. This has to be interfaced, and this is part of our planning. And then we know we can demonstrate like that there's organizational impact. We've got wide engagement and use. And we have now a senior level champion who is recognized as the leader in this area and then has the ability to interface institutionally with all of the things that are happening and has a seat at that table. So let's go through each of those areas then. So pathology informatics, we'll start there. We've got a director. This is his smiling face here. He's Robert Black. He has a dedicated team of 3 people. These are not LIS people and they're not IM people. They're a bridge, but they do need to have this IT workflow experience, and they also need to understand the lab system. They're largely remote, but when they're here, they have a rotating schedule. They're here with our managers and lab. They're right close to the lab. And so, and with our LIS people, but they really are the bridge between our IM groups, our LIS, as well as vendors and different contractors. And the thing that is special about these people is that it also requires them to have access that probably parallels that of our LIS and IM team, as well as the security, which again, for us as an organization was something that we had to navigate. I think the benefits of this to our approach here is that we take a holistic, integrated, and standardized approach. So again, if a lab is bringing in a piece of software here, it's not just on that lab. This all rolls through this pathology informatics group, and they make sure that it's given the same treatment and held to the same standards across the board, and it gets integrated into our entire system. Because we have this ability to bridge all of these groups, projects are getting done. And I'll show you, kind of an example of that, that because we're able to facilitate these discussions, we're able to scope more smartly than we would before. In the past, we would have our lab folks interacting with IM or LIS or vendors, contractors, and they would be being asked like really technical questions, or they wouldn't even know what to ask. And so we'd get through the scoping, we'd start implementing, and then we'd find these huge issues that were coming back like, oh, well, lab, scoped this and you didn't tell us it was this. Well, I mean, these people don't know that, that we need a virtual machine that is a Unix operating system that's beyond the boundaries of our lab people. And so this is really where this group has been extremely powerful. And I would say that what they do for us is they help us drive the informatics maturity arm of our capability. This is an example that Rob gave me of, he's tracking all of these things, our system architecture and interfaces. And so you see, and we're a relatively small department. I'm sure your department is much larger than ours. We are, a single standalone pediatric hospital. So we're worried about things in our own house and then, at our labs that are in a couple satellite places, but we're relatively simple and, there's all of this going on. So we, again, made some decisions about, how are we going to interface things, how we're going to run data through with the guise of things being integrated, which we're always working on to improve, but also that it's available to us for our analytics pipeline. And so you'll see that in the last 5 years, there's been a number of new interfaces and devices that get added to our system and integrated. There's a whole other set of them that are standalone applications. But what you'll see here is that there's been a lot of new systems added. So this is, again, in the last 5 years, we're just adding more informatics systems. And then there are a number of things that are in red here where we're desiring an interface. So we've got these on our project map of how are we going to interface these things. So just to give you an idea of the scope and the scale of things that Rob's team works on and why this was something that we had to dedicate a team to, and it wasn't good enough anymore just to be relying on external departments to do this or on our own lab staff and managers. So what this means, again, is that we're able to, because we can scope more effectively, we can follow these things smartly, we're able to get a lot of projects done. So this is an example of our fiscal year 23, the projects we completed, and you'll see it's a lot of things in parallel. We've got replacements, which of course are required. We've got new instruments that are being added, new technologies here, as well as a number of upgrades. So that's the other thing that Rob keeps track of, is where our systems in their life cycle and what upgrades are needed or what replacements are needed. That, again, for that to fall to labs is another thing that we weren't doing a really great job of in all areas. Okay, so bioinformatics is directed. We have a director, Patrick McMullen, who's here. He has a dedicated team of 5 folks. They're a mix of clinical and research roles. So he's got one person who's fully research, 100% research, and then he and himself and another folks are part-time research, part clinical, and then he's got other people who are full clinical. And so he is our second bioinformatics director. With his recruitment, we actually changed this a little bit, that he also directs the bioinformatics in our research institute, which is why he has this melded team. But of course, our bioinformatics group requires specialized technologies and analyses. So they interact with Rob's group, but they have a very specific scope and needs that are different than some of the larger pathology informatics. And so they are doing like Rob, they're bridging with Rob's group and then with all of these other areas, both internal and external, and including researchers. And so again, we had to navigate with them. They require, different access than like a normal lab director would or normal lab staff would in security, but also, appropriate computational resources, including like how we spec their laptops that they have and, giving them access to cloud-based computing. And so this group is important for, I would say, enabling discovery and pushing adoption of new technologies, particularly in our molecular lab. So here's an example of that. So if we think about our medical exome, this is a next generation sequencing assay that we do in our molecular lab, covers the 3,000 to 4,000 genes that are known to be associated with human disease. And so back in like 2018, this was how it went. It was all based on local compute. It was taking days to do just the alignment and QA part of it. And then that data would be, processed again on local machines using, these two software platforms that were our tertiary analysis tools. So then the next step was in 2019, we moved to AWS Cloud, and that really cut down our time for the primary and secondary pipelines from days to hours. And I guess I also want to point out that at this time, we had 2 lab directors who were signing out. They were really the technical lab directors. We didn't have a bioinformatics director specifically at this time. And we had 2 people who were our bioinformatics staff. One person was someone who had been a long time molecular tech who was interested in this and kind of bootstrapped his way to becoming a bioinformatics person, and then another person that we hired with bioinformatics actual skill set. So we're still with about 2 people. We've now hired a director at this time, but we've cut down the time. But now we're at a level of real sophistication. So now we've added a bioinformatics director. We've added another molecular lab director. We have expanded our staff on the clinical side to 4 staff, and we also added 3 genomic analysts. So, and all the while, we've had the same number of techs, of wet bench techs. And so really our growth in our molecular lab has really been around how do we process and handle the data. And so this is all cloud-based. It's using these containers, so there's a lot better version control. It's automated with this orchestration engine that's called Nextflow. And instead of things being done sequentially, it's done in an automated fashion in parallel, and everything is done in the cloud. So this is a much better way, and it's allowed us to scale and then also start thinking about beyond medical exome, moving to whole genome and whole exome. So in the data literacy and computational thinking arm of this, this is really about, I'll draw your attention to this little graphic here. So I think, when I think about who needs to interact with data analytics and these types of applications and tools, I think that in our departments, we are going to have consumers who I would say are people who need to be data literate, and that should be everybody. We're going to have a smaller number of people that I would call the producers that need to be fluent in data analytics. And so this means in data science, this means that they can actually create applications for these consumers to use. And then I would say you're going to have at least one, but likely more than one higher level faculty director person that I would call a champion. And these are the people who are really the change agents. They're the defined leaders. They have the technical skill, but also the effective leadership to really change culture and keep this as an area of expertise and asset in your department. So a number of things that I've been doing and we've been doing here, both with residents and fellows, with our staff, and both internally and externally, to really try to build data literacy and computational thinking. And this, again, as I said before, this is an absolute requirement for data-driven culture. It's not something that we train people today in residency and fellowship programs very well. And it's also not something that's part of medical technologist or medical lab scientist education. So we have a lot of catching up to do, but we need to start building this into the pipelines for the workforce of the future. Data analytics is an area that we have worked with an embedded analyst. This was an approach that worked well for us. We have a leader who is me that's helping set the priorities for this. I help interpret user requests. We've got an intake system, and I'm the bridge between our embedded analyst, who's here, Zach Zhu. Zach is appointed in DPLM, but also in data analytics and reporting. And so that facilitates his ability, again, to have special access, to know who within the data analytics and reporting and IM groups are the right people to go and help us navigate different parts of the process. But in order to do this well, we have to have access to data and tools. And this is really the group that's driving the data analytics maturity part of our efforts. And so when I think about what we've done so far, we've got this pipeline where, we have an intake system. We do some discovery and scope where we work with the users who have asked for a specific data project. We then do a rapid phase of designing and development, getting feedback from those users. Once we agree it's ready, we put it into test. And typically we're comparing an existing, Excel type of file or some existing report that they're getting from a Crystal or a Clarity report to what we've built for them. We're validating that everything makes sense, that people trust the data, they understand it, and then we implement it and deploy it, and then we're monitoring it over time. And under all of that is a requirement for project management, change management, and governance, the governance piece was not something that I think we really thought about a ton or enough when we started, but as we've deployed things and people have asked for access to things, we've really had to think a lot more about who should have access to certain pieces and how do we integrate with the overall data analytics efforts at the hospital, and again, building data literacy. So we're often showing people now, we're elevating reports. They have more autonomy in what they can do with the reports. They're more interactive. So we need to make sure that as we're giving people new visualizations, giving them new tools, that they actually know how to use them effectively so they can take action and on the data and interpret it appropriately. So when we talk about data analytics maturity, there's 4 typical phases of this that go from descriptive to diagnostic, predictive, and prescriptive. And we have covered all of these. So, the goal for us, I think people really want to be in the predictive analytics and maybe prescriptive analytics, which are like the advanced kind of stuff where you need machine learning and higher order computational methods. And that's all fantastic. There's a lot of exciting opportunities and benefit for that. But I think as departments, like we shouldn't we need to be focusing on all of the benefit that we can gain from these descriptive and diagnostics and really making those bolstered or more robust. And that's where we started, and we've slowly been progressing. Then I think about, so that's all internal to our department, but I think about what this has done, how we've influenced the digital transformation at Lurie Children's. So as I mentioned, this is also, work that at the institution, they're trying to do this for the whole hospital in general and in different areas. And I think of a number of things where we were the first, and we've really pushed the institution to bring in a technology that now has other use cases outside of our department. That includes the AWS cloud environment. Lurie Children's is largely a Microsoft shop. And so we had Azure was our cloud, but when we were doing our evaluation in 2018, 2019, it was clear that for bioinformatic workflows and pipelines, the Azure option just wasn't as well developed as AWS. So we really pushed for AWS. That's been now something that other people have been able to use and leverage in the institution. So that was really good. We, again, in our bioinformatics group, really pushed for, instead of having an individual code repository, we needed to be able to share our programmatic code and make sure that we were documenting these things and that we had good version control. And so we really pushed the institution to get an enterprise account for this, which is not something it had done before, but is now something that our data science at the hospital also uses. I'm going to talk in 2 slides at the end about this pipeline we had for extracting information from documents through optical character recognition and then processing that data through natural language processing. That was a pipeline that we, again, developed and brought in-house for genetic report use case, but is now being used for note abstraction more broadly in the hospital. We generated a custom Epic data model so that we could integrate our biorepository inventory data with the Caboodle Epic data warehouse. So that has been very good, and that then gave us the skill set as an institution that we can use this in other for other areas who want to create these custom data models. We didn't have that before. We implemented Epic Genomics module, and then we were one of the first departments to actually create a department-specific data mart. So something that is beyond just what is available in general as the Epic data warehouse. So let me talk through now some examples of the value that we've gained from all of this work. I'll start with a descriptive and diagnostic analytics approach, and this is really how using analytics helped us target and monitor improvement efforts in critical callback compliance. I know this is something that everyone has to do. So at Lurie Children's, we currently are using SunQuest, and so we document critical calls in this SunQuest callback module Monday through Friday during the day from 5 a.m. to 5 p.m. We have a call center that are making these critical calls. Outside of those hours, it's our core lab techs that are making these calls because that's largely where the critical calls are happening. So what we should be doing per our policy is calling to a licensed independent provider within 30 minutes of us knowing the call and having them acknowledge it. Because sometimes it's not always clear who that person is, or we can't get a hold of them, or they don't want to, take that critical value for that particular patient. I'm sure anybody who does this knows that these are very common problems. We created what is a shortcut, right? So we know for our inpatients, there's a nurse who's typically sitting outside of the bed, outside of the room, and is responsible for either 1 or 2 patients, and they'll gladly take that result. And then we're relying on them to make this connection, to communicate it to a physician. When that little, top of the triangle is intact, everything's fine. But what happens is if the nurse gets busy and this breaks down, we then have patient safety events. So we really needed to move to follow our policy, which is there for a very good reason for patient safety, and really adhere to that and improve our compliance in this way. So the way that we were monitoring this was with an Excel report that was not automated. Every month, one person in our lab would get an extract from SunQuest that was emailed to them. They took about 3 hours basically to parse that data, decide what they were going to exclude, and their goal was to get this done by the 15th of the following month. So by the time we had the report available to us, it was, if you were talking about the data from the first of the month, it was 6 weeks old. So if you needed to investigate anything, it was really, not effective. Again, there was a single person who did this in our lab, and it was based on a very macro-laden Excel file that was built and maintained by a brilliant pathologist. But when he retired, and it broke, the tool broke, it was really difficult and we couldn't fix it. And the data model was also subjective. So the person each month was going through and deciding whether or not we should include something. And what we found during the validation was that sometimes those weren't the best decisions. They were well intended, but they probably weren't really weren't right, and they weren't standardized. It wasn't interactive. It, in fact, couldn't track whether we were calling licensed independent providers. And again, it was just inadequate, the documentation. So we moved this to Microsoft Power BI. It's automated now. It directly queries our Sunquest database. It refreshes 3 times a day. We have a broad user group that includes our call center, our techs, our managers, directors. Lots of people can see this report and use it. Because it's hard-coded, we've got a defined and constant data model. It is interactive. It tracks calls to LIPs. And we now are able to document the changes. And again, we can go in and see how things are calculated and what's excluded. It has multiple pages, but this is one of them. It's web-based. And there's a lot of things on here, but I want you just to focus on this part that's green in the middle. This is the part for the pre-intervention. This is data from 2018. You can see that only about 50% of the calls were going to licensed independent providers. And so we at first worked with our PICU to create a call tree and make sure that we had a new workflow in place with them that worked really well. Then our HEMONC group, so the 2 groups that were had the most overdue critical calls were our PICU and our HEMONC area. And so we had then a HEMONC fellow that was also interested in doing this in that area. And so we implemented a similar type of intervention there, and now we can monitor that as a whole, where now more than 80% of calls are going to these licensed independent providers. And then that person was so motivated that we worked with them to publish this report. But if you look at the gray line is all of the non-HEMONC areas, we're at about 55%. In HEMONC, before we started this process, we were at 2% to licensed independent providers. That's because we were calling directly to those nurses. But once we implemented the intervention, that went up to over 75% and has really stayed there. And so in this case, analytics really helped us identify an opportunity, but also who is the targeted partner that we could work with, and then we could monitor the impact. So this is really thinking about how do you change your service? Instead of being reactive to things, how can you identify these opportunities, know who you should be working with, and then start creating collaborations. Predictive analytics, I'm going to talk about how we improved our efficiency of peak and result review in our mass spec lab. So you probably know for clinical mass spec quality assurance, there's a lot of peaks that get reviewed. So this is an example of immunosuppressant drug tacrolimus. We look at peaks for the drug itself, but also an internal standard. And we're looking at things like, is this peak in the right place, in time? Is the shape good enough? What's the ratio of these 2 areas? Lots and lots of rules get applied for every sample and every peak. And these rules may vary by analyte. They do vary by analyte. They vary by peak, but also by instrument. And so this is something that, techs were spending their time going through, and you're expecting that they're applying this subjectively and constantly, which is probably a big assumption, even for the best intentioned people. So what we decided to do was implement a software, and this is here in the orange. But again, we didn't just implement the software. We said, we're going to automate the entire workflow so that we're going to also eliminate manual entry. We're going to, make things faster and more integrated. And so that's what we did. We start with our laboratory information system. There's a work list that's created. It's picked up by our sample prep robot, which creates the plate map. So the robot knows what samples in what plate. Once that's aliquoted, that sample table is uploaded to the mass spec, which again, it tells it which sample is in which place when it makes the injections. It does the analysis and uploads the sample table, so the map of the samples with the raw files to this data processing, which then does automated peak identification integration. It also applies a lot of auto verification rules. So now we can review peaks by exception versus looking at 100% of the peaks. It generates a result that we then have interfaced into our LIS. The other benefit of this is that because we've digitized this data, we're also extracting all of that information into a database that we can then use to monitor across batch quality assurance and for our method development. So, we have a good idea of what is the distribution of our signals, what is the distribution of our ion ratios, things like this, that typically it would take us a lot of time to do, or we'd have to comb through multiple Excel spreadsheets for in the past. So what did this do for vitamin D? So before the project, people were reviewing 100% of 6 peaks for each of a 96-well plate. We had this subjective review. Then someone would go and manually enter 2 values. So a value for D2 and a value for D3 for each of the 84 patients. Someone else had to stop what they were doing and come over and verify what was in the system matched what was on the paper. And this took 2 hours on top of the analysis time. And was manual entry and error prone. So after we implemented the project, now people are only reviewing by exception. It's about 10% of the peaks get reviewed. That was based on analysis that we did after we implemented. We've eliminated manual entry. And so now to report 84 patient samples takes 15 minutes. And this then became the way that we then transferred over every assay in our lab. And this is what we do when we bring on a new assay now. What I didn't know at the time, so we just figured this out. We didn't know how to do this, but I was told that, the August 2023 CAP checklist, if you have a mass spec lab, this is a new checklist item that's specific for validation and monitoring of mass spec data analysis tools, because these are becoming increasingly important. And it's really about how do you validate this when you make changes or, in real time annually. And actually it cited the paper where we did that vitamin D work. So I did get to joke with my bosses, this is a good way to get cited by CAP, but in a good way. So my final example for our analytics is the prescriptive analytics. So how do we optimize assignment of inpatient phlebotomy staff? So prescriptive analytics is really telling you what you should do. The idea here was that we had a number of phlebotomists on the inpatient unit who were being deployed, and there was complaint from the staff that the workload was really imbalanced, and this was being used in a punitive way. If you weren't in favor with the manager, then they would assign you to the phlebotomist role that you were running around trying to get all these samples done, and other people were taking a lot of breaks and weren't as overloaded. When we looked at the data, we did realize that there was an imbalance in the workload, and we felt like we could do a better job of balancing this with a prescriptive model, and then that would lead to improved collection response times. So really, this is a question of how do you cover the same number of requests with fewer staff? So in our unoptimized approach, we had 4 people. They had the same assignments Monday through Friday, and this was based on perception and history. It wasn't really clear what data or purpose it was assigned. It just was there, and then that was what we used to schedule people. In the optimized approach, the assignments vary by day because they're based on things like volume. And I wrote an integer goal program that uses expected demand based on historical data and some other factors to balance the workload among phlebotomists. This got deployed in Excel, and in the background here is running an open source, what's called solver. So it's a linear algebra system where you put in, what are your constraints, and you're trying to optimize a problem. So in this case, what we're trying to optimize is we're trying to deploy people to locations so that they have a balanced workload in time. And so what we're solving for is to minimize the deviation from the mean workload. And so, this is somebody's over here by about 6 minutes on this one, but they're under by about 6 minutes. So that's pretty good. And so what happens here is you can adjust, these are the little dials you can adjust in the data, the complexity. So we also recognize for each of these locations, it's not the same when phlebotomists go there. When they go to the NICU, it's going to be pretty complex collection. And so we talked about two different cycle times. So if it's an easy or a normal phlebotomy, that took about 7 minutes. We measured this ourselves and looked at literature. If it's an extended or a longer one, that's a 12-minute one. And so the complexity is what, is if you have a higher complex, you're using more extended phlebotomies and less normal phlebotomies. Hopefully that makes sense. And then we also looked historically at how many phlebotomy requests we had per location. And so when you put that in and solve, what you'll get out is this series of zeros and ones here. And what this is telling you is that for the 3 people, how do you optimally assign them? And so for phlebotomist 1, that you want to send them, they want to collect all the orders from locations 4, 6, 7, and 9, phlebotomist 2 to 2, 5, and 8, et cetera. And so the way that we implement this is we then program their handheld device, that phlebotomist 1 handheld is taking in all orders from locations 4, 6, 7, and 9. And so that's the way this goes. And so we have to be careful about, initially I had this great idea that because mathematically you can solve it, that we would do this, make adjustments 3 times a day and all of this, but then it becomes really like practically that's not feasible and the juice just isn't worth the squeeze. So we effectively monitor in the background these inputs like the volume, and if we see significant deviations, we go back and rerun this, and then we'll decide if we want to reprogram if we're going to get a large deviation. What did this do? So when I looked at the manual logs of how long it took people to do the daily rounding in the morning, what we found is that the orange represents the unoptimized. So this is again kind of COVID-ish times, but in 2019, unoptimized, we had 4 people and they could complete the rounds in about a median of about 150, 180 minutes. When we didn't have enough people during COVID, we saw that the rounding times increased when we only had 3 people, and that was statistically significant. But when we took 3 people and we optimized the assignments, we could, with 3 people, cover the same number of requests, same complexity, like we investigated the volumes and everything in the background. There was no change. We could see that with 3 people in an optimized format, we could get to very close to what we were doing before with 4 people in the unoptimized. So again, the analytics here helped us identify an opportunity, and we really developed and implemented a solution. I'm going to talk quickly about our bioinformatics. So we, like most places, are increasing our usage of next generation sequencing, testing for diagnostics of genetic conditions. The side effect of this is that it's driving discovery of what we're calling ultra rare genetic conditions. So these are things that were only identified due to this non-targeted large scale genetic testing, like whole exome and whole genome. These are kids who have a presumed diagnosis, a genetic underlying cause for their symptoms, but there's been no previous description of a molecular cause of their disorder. So some of those get diagnosed, but then there's many of them who go on what's called a diagnostic odyssey. And so this is really like, how can we improve the care for these patients that even if they have whole exome, whole genome, there's still no genetic cause. So maybe there's not a genetic cause, but more likely it's that there's one of these kind of problems, that the variants are not detectable by the current methodology, that there's inconclusive variant results that we don't, because we don't have functional or phase data to better understand it. Or, when we get these huge sequencing, it could be that one of those disease-causing variants was detected, but it wasn't prioritized as something that was needed to be evaluated, so it's excluded from the reporting. And so we've got a number of solutions, orthogonal ways that we can investigate this. But I would say that every one of these, in order to be able to do this, we have to have a really robust pipeline. Either we have to further develop, a pipeline that exists, let's say for the RNA-seq, or we have to integrate it within our current system, or we have to develop it de novo. So it's really that bioinformatics is enabling these types of new approaches. And that is one of the pieces then that has helped Lurie Children's really become recognized as better serving these patients who have these ultra rare or rare disorders. So it's not just the clinical genetics, it's the mix of clinical genetics with the bioinformatics and the lab work as well as research. And so I'm going to talk quickly about the future because I'm running out of time. But we're thinking about traditional AI. about the ways that we can improve AI assisted interpretation. So one of those is using ChatGPT. The other way that we've been using generative AI is in, as I said, this intelligent document processing. So we can extract information from genetic reports and get discrete information back using optical character recognition and natural language processing. But we've also been applying that to requisitions, but using large language models for that work as well to see how well that works. And it's doing a pretty good job, even though it hasn't been trained in these things. But again, it still requires human intervention. Another area that I think we need to do more in, and we've got a good foundation for, is really building out data analytics around our stewardship. I think this is exciting, and we've got plans for how to expand that. And then, as I said, the last thing is something that we haven't really done a lot on, but we're getting started slowly, but this will become the next area of focus for us is digital pathology. And so with that, I will thank you. That was a whirlwind tour, but hopefully gives you some oversight into what is this digital transformation and how have we handled it at Lurie Children's. And thank you again for the invitation and for your attendance today.
Okay, thank you very much, Shannon. That was absolutely fantastic. Very, very interesting. I have a question, and that is, with the comprehensive activities that you're doing, if you could talk a little bit about the financial support from the department in order to facilitate and make all of this possible.
Yeah, so the financial support has been for a fraction of my salary to be the vice chair for computational pathology, like really to have a strategy and a vision and to lead it. I think having that title has been very helpful in that it's given us, like I said, these special sort of access and tool and recognition among other people in the institution who are focused on this for the hospital. So we're really well tied into the data analytics and the informatics work within the hospital because of that. It also supports a half of this embedded analyst that we share with the data analytics group. And then it's supporting that entire group of pathology informatics, which is the director. We started with just one person in 2019, and now we've grown that through justification by having many, many more projects and informatics systems added to us. To that group is a director and 3 people, and then the same with the bioinformatics. So that was a new faculty that we added in 2018. We had 2 people, but the justification of the research work that's coming in, that's offsetting people's salary with grants, but also the clinical need has justified the growth of those groups as well.
Great, thank you very much. Dr. Day, I see your hand is up.
Yes, so thank you very much for very nice presentation, which it's a little bit out of my immediate area. So but I saw that at the beginning of your presentation, you indicated that the digital pathology, which involves microscopy, is something in the future that you guys are planning. So do you have an idea of what kind of approach that you have in mind in terms of being able to acquire the data by scanning the slides, but what will be the readout and what kind of analytics are you planning? I'm not sure if you already have that defined yet or not.
We don't. It's a good question. So we're about to start trying to figure that out for the scoping. I mean, we don't even have a scanner. What we've done right now with the getting of the pediatric training set, we've taken our slides and have gone across the street to Northwestern, our partner hospital, where they're much further along in this than we are. But I think it's important to us for research, but also even in pediatrics, we're starting to see that many of the definitions of disease are related to digital aspects versus just what would traditionally be viewed through a microscope. And so we recognize it's important for clinical, but also for research. So I think, we'll get to the place where we will be doing some development and refinement of the classification tools and applications, but we're still very early in our process. So I don't have any wisdom to share on that, unfortunately, at this point.
And one other thing, so in one of your slides, I was able to recognize some other third-party data collection systems. So like you have FileMaker Pro, for example, And I think you have a couple of the other things that it's one of those slides that I think Dr. Black shared with you. So so most of the analytics is outside a particular platform / LIS system. So how extensively did you have to adopt other kind of software, and how do they talk to each other, and what kind of decision making goes into that?
Yeah, that's a really astute observation. So that's what I was trying to get across about thinking about the broader strategy and the planning. So now when we think about bringing things in, or we think about upgrading, FileMaker, for instance, we really think about how do we integrate that database and ensure that we have access to that data. Because you're right, we've built an infrastructure in the background that has a lot of data feeding into it. And then we put tools on top of that that are outside of, typically outside of any individual application, because they're using that integrated data in the background. And so that's something that we continue to work on. And some of those data systems are not yet integrated. And sometimes for some of them, it's just that we haven't gotten to it, but others there's a technical limitation that we're facing. But that is our goal, is to be able to better integrate things. And so then, even the same when we think about a new middleware program, we're talking with the vendor to find out how can we get back end access to that, instead of just settling for implementing that, knowing that we're never going to be able to access that data in the back end. And if we can't access the data in the back end, we think of how can we move it to another location where we could stage it so that we can ingest it into our pipeline in the back end.
So do you see a situation where it's possible that there's going to be just one application that does it all?
I don't know. I don't think so. In everything I've seen, I have not seen a killer app. I think that's a great question. But even, when I think about digital pathology and all of these things, everything I've seen is that no one tool is the right thing for everything. And so I think that's why you have to have this agility and the ability to assess different technologies and understand what their strengths and weaknesses are, and have the flexibility to utilize the thing that is the best for the job. And I do think that that's some of the stumbling that we've made as a department in the past. We would bring in something and just try to have it do everything. And so that's in fact, for our molecular lab LIMS, I think people would say that is the case. So we brought it in, it was good at one thing. And then there's been all of this customization over time to try to make it be really good at other things. And it's still just not good at that. And we've invested a lot of time, and it's very far from the foundation. So it's also difficult to maintain and keep updated. So I don't think that there's a killer app. I think you have to have flexibility and be able to really assess what are the strengths and weaknesses, and really think strategically about what are your requirements, so you can assess that when you're bringing something in.
Thank you.
Okay, thank you. Any other questions or comments?
Hey, Shannon, how's it
Hi,
going?
Jesse.
Hey,
Nice
Jesse.
to see you.
Good to see you. I saw, great job. Very impressive, first off. But I saw you were talking about the mass spec data automation. And are you using that Indigo program? Is that what you're doing? Okay.
Yep.
Can you comment on the price of that? So that's always been kind of a sticking point with the mass spec. So we have, a service contract for 30 grand a year. And then the Indigo software, I think when I looked into it one time, it was 20 grand a year. So I'm 50 grand before I start digging the basement. Can you comment on how that's worked? And
Yeah. So to be very honest with you, we had Ascent since 2016 or 2017. At the time, we were paying way more than we should have, but I knew that it was really important, and I really wanted to get it. And it happened to be, I kept asking, and was told no. And then it just happened to be that the institution was super interested in automating things. They were really looking for projects to prioritize that could automate. And this is one that it's very easy to show how you can really improve your utilization of people, and how it has a huge impact, especially if you're looking at highly multiplexed things or high volume things. It's very easy to show how you can improve utilization of people and reduce turnaround times and things like this through automation. And so we got it. And we, at that time, the pricing structure in 2016, I don't know when you last looked at it, but the pricing structure then was really more for like reference labs. So we were way out of our league. But I think Indigo then changed their pricing structure in the last several years because they realized they were outpricing a very important part of the market, which was clinical labs. And so now it's very different. And it's much more in line with what I think it should be. But it is expensive, but it's, you buy it, but then, like I said, people aren't manually entering stuff. And then also I know that the review is very thorough and it's systematic. And what I didn't show here is that when we did the analysis, I also saw that my techs are doing less manual integration, which to me is very important, than they were with just using the instrument analysis. I don't know why mass spec vendors have not gotten on board and like created something like this themselves for their own software. I think that's us as an industry needs to really push this. I think people have tried, but now I think there's more and more clinical labs that are using Ascent. So I don't know when you last looked at it, but I would encourage you to take a look again, because I do think the pricing structure has changed quite dramatically, and is more in line with what you would expect. But for us, it's a very important tool, especially we're thinking about, amino acids is next here, and thinking about having people manually enter 20 some values for every one of the 84 wells or something is just going to be incredible. So
yeah, no, that's great. Because we do like our drug confirmation panel is like 127 MRMs per patient, right? So
I think from a quality perspective and then also the efficiency, you should I can help you like with whatever you need from numbers, but it seems like something that should be a requirement for you to be doing that efficiently and effectively.
Sure. Thanks, Shannon.
Mm-hmm.
Okay, well, we're at 9 o'clock. So I think we should probably wrap it up here. Shannon, this was absolutely fantastic. Very, very impressive and really inspiring to see what you've been able to do at Lurie Children's Hospital. So thank you so much for giving us the seminar this morning.
Thanks. Bye, everybody. Take care.
Bye-bye.